Here we have two similar triangles. Now I'm using the naming convention that is used in trigonometry, where capital letters are used for angles and small letters are used for sides. Notice that small side A is opposite angle capital A. Similarly, small c, the length of this side, is opposite angle capital C, and small b is opposite capital B, and we have the same for this triangle here. Now we have to prove that A divided by D equals C divided by F equals B divided by E. What we do is we move the smaller triangle into the larger triangle. So I will move this point of the small triangle to this point of the large triangle, and we move this triangle in such a way that this angle D here will coincide with angle A. So these two triangles are actually set up so that the sides are parallel. This side F is parallel to side C, so we only have to consider a translation of the smaller triangle onto the larger triangle. So I'll translate this side onto the larger triangle, then I'll translate side E, and finally side D. The proof uses the theorem about a line in a triangle drawn parallel to one of the sides of the triangle. So to apply that theorem, we have to show that D prime is parallel to A. Well, of course, we know that angle A is equal to angle D, so that this triangle will fit exactly up here. Now, what about D prime, which is the image of D? Well, this triangle up here with sides E prime, F prime and D prime is obviously congruent to this triangle, because this triangle is the image of this triangle under a translation. So the angle in here, which I'm calling E prime, must be equal to angle E. But of course we already have the fact that angle E equals angle B, because the small triangle and the large triangle are similar triangles. So E equals B, and E also equals E prime. So that means that E prime must equal B. So these two angles are the same. But you see that these two angles are corresponding angles. If these two angles are equal to each other, then this line D prime must be parallel to the line A. And from that we can use a previous theorem, because we have this line drawn parallel to this side of the triangle. And we then see that this distance here, which is C, divided by F prime, this distance, must equal B divided by E prime. But of course F prime is the same as F, and E prime is the same as E. So we end up getting that C over F, that is the blue side of this large triangle divided by the blue side of the small triangle, equals B over E. That's the green side of the large triangle divided by the green side of the small triangle. So we've proven that these two ratios are the same. Now, to prove that these two ratios are equal to A over D, we can translate this triangle into, say, this corner of the large triangle, or this one, doesn't matter. So I will translate it under this translation here. So this triangle here gets mapped into this new triangle, E prime, D prime, F prime. Angle E gets mapped into angle E prime. E is obviously equal to E prime, because this triangle is congruent to this triangle here. So we just move this triangle into this triangle. I only had to translate it here because the sides of the small triangle and the big triangle are parallel. But if they're not parallel, you might have to do a rotation. Just move the triangle so one of the corners coincides with a corner of the big triangle, and also that the angles overlap. So angle F is equal to angle C. Now we know that angle E equals angle B, because the original two triangles are similar. This triangle is similar to the big triangle, Angle E equals B and angle E equals E prime, so that means that E prime equals B. And if E prime is equal to B, it means that line C is parallel to line F prime, because then E prime and B are corresponding angles. So this line is parallel to this line. So we can use a previous theorem. We can take A, the length of the large red line, and divide it by D prime, and that will equal B divided by E prime. So that's the theorem about a line being drawn parallel to a side of a triangle. I didn't state it here, but I did state it in the previous part when we mapped this triangle up to the top corner of this large triangle. But of course D prime and E prime are both equal to D and E. So now we've shown that A over D is equal to B over E. But previously we showed that C over F equals B over E. So the three ratios are equal to each other. And that's the end of the proof.